Have you ever wondered what exactly is the universe made of? According to the cosmological model, our universe was born 13.7 billion years ago by a huge explosion that gave birth to our space like we know it nowadays, the Big Bang. Everything that exists was born in that immense explosion. Science development led us to more and more sophisticated and accurate technology to investigate the cosmos. And little by little, astronomers and physicians have learned a lot about the universe, discovering stars, stardust, planets, satellites, asteroids, galaxies, nebula clusters of galaxies, and so on. Until recently, we thought to be well advanced in the comprehension of matter distribution around the universe. Nevertheless, starting from the last century, observations suggest that there is far more to discover. As a matter of fact, all that exists in the universe seems to be much more than we can detect. The mass we can see and measure is only a minimum fraction of the whole universe. Yes, because the larger amount of matter in the universe is invincible and undetectable by our instruments. Until recently, we thought to be well advanced in the comprehension of matter distribution around the universe. Nevertheless, starting from the last century, observations suggest that there is far more to discover. As a matter of fact, all that exists in the universe seems to be much more than what we can detect. The mass we can see and measure is only a minimum fraction of the whole universe. Yes, because the larger amount of matter is invisible and undetectable by our instruments. It's like an immense halo that permeates the cosmos without emitting, absorbing, and reflecting nor light, neither electromagnetic waves. This is the dark side of the universe. This is dark matter. Physicians say that only 15% of the matter in the universe is made up of detectable ordinary mass. The overwhelming majority is made up of something that we can't detect directly. So, scientists called it the dark matter. The name dark is due to the fact that it doesn't shine, it doesn't absorb, and it doesn't reflect light or any electromagnetic radiation. It's like a phantom. We can't see it. It's completely invisible. Do you want to know how it's that impossible? Let's rewind the tape a bit and go back in time. The first evidence of rotational velocities. Since the end of the 19th century to the beginning of the 20th century, many scientists were interested in what we called obscure stars and dark gases, little luminous matter that couldn't be identified with telescopes. In 1877, the Italian priest Angelo Secchi, expert in stellar spectroscopy, in a paper asked himself questions about the presence of scattered dark masses in space. In 1933, the Swiss physician Fritz Zwicky was trying to understand the behavior of clusters of galaxies. In particular, while observing a cluster of 1,000 galaxies, he says 150 million light years away from here, he found some anomalies in their motion. In fact, they were rotating with a speed about 100 times faster than what the theory expected, as if the total mass of the cluster was about 400 times higher than it was. In other words, the gravity effect of the cluster was too low for such fast orbits. Therefore, Zwicky argued that there had to be much more gravity and more mass than it what appeared to keep together these galaxies with those high rotational speeds. The Swiss were the first to use that term, dark matter, to express that lack of matter. If these observations were confirmed, we will get the surprising result that dark matter is present in larger amounts than luminous matter. Unfortunately, they weren't very popular within the astronomer community, so because of their short-tempered behavior, their idea at this time were absorbed and set aside. So far, this was considered an issue due to the mistake of the process and the measurement because of the technical limitation. It was essentially believed that the missing of the gas was made of faint stars. Planets, meteors scatter gas in interstellar spaces. Several decades passed and the thing came back to the surface thanks to the work in 1974 of some Princeton cosmologists who claimed that there are good reasons to believe that the mass of galaxies had been underestimated by a factor of 10 and more. The turning point occurred at the end of the 70s, when the American astronomer Theo Robin was working on the motion of spiral galaxies, and as the same thing that Wiki claimed 40 years ago, Robin and her colleague Ford had studied and measured the rotation curves of about 20 galaxies, and had found them moving away from the center of the mass velocities didn't decrease according to that data. Galaxies couldn't stay in balance. You should have flaked off when the outer stars departing from the target. There had to be much more mass in there. To understand this concept and explain all these conclusions, we need to do a short digressions about Newton gravitational and Kepler laws. Kepler laws are deduced directly by Newton gravitation. All rotational systems and then can be modeled as a heavy central mass with some smaller and lighter objects orbiting around it, and it can be investigated by applying Kepler laws. The rotational speed only depends on the distance from the central mass and on the matter of mounting in the center. You must be sure that this is not the end of the video. My friend Aus will explain the second part of the dark matter. I am Noaman al-Azami, and thanks for listening. Assalamu alaikum.